Alrighty, Math 20-3. So we are on now to chapter 2, which is graphical representations. Now this is a super important chapter because we are met with graphs and data and all these types of things on social media, on the news, everywhere you look nowadays. And you have to be able to decipher and understand graphs and numerical values such as statistics in order to make up your own mind based on what you're given, especially in the news nowadays. So that being said, let's learn a few definitions. So a broken line graph, you've all seen a broken line graph. Okay, so a broken line graph is simply where you have your x-axis and your y-axis. So remember that this guy here is your x and this is your y. Okay, you have your x and your y-axis. Now remember that you have an independent variable, which is always on the horizontal x-axis. So this is the independent variable. This guy here is your dependent variable. Now, these often confuse students. Just understand that an independent variable is something you cannot change, okay? And the dependent variable is something that will depend on what's happening in your x-axis. Okay, so I wouldn't focus too much on that, but just understand that your independent variable is on the horizontal x-axis. Your dependent variable is on your y-axis. Now, you also want to understand what a broken line graph is. We've all seen a broken line graph. That's not a very good color. Let's use red. It's where you're given data points, okay, that kind of scatter throughout. And then what you can actually do is you connect these data points by joining them with a line. Okay, this is called a broken line graph. And this is really useful because you can see what's called a general trend. Okay, general trend, what does that mean? It kind of shows a pattern. Okay, so when you have good statistics, hopefully you can see some patterns. So this one we could say is a positive, okay, and it is increasing, right? As we go to the right, it gets bigger and bigger and bigger. Okay, let's do a few questions. So if we kind of look here, we can see what's happening. The graph below shows, the average snowfall in Regina and Saskatchewan by month. So clearly we have summer months here. So your independent or your dependent variable is how much snow you have. Your independent variable is your month, right? We can't change what's happening in the month, but the snowfall changes depending on what month it is. And we know that in Canada for sure. And we can see that there is no snow. So this is obviously summer, which makes sense, obviously, because it's June, July, August, and September. We kind of have our fall seasons, and then we have winter. Okay, and we can see that winter is over here, and we've seen this before. We've seen the random February month where maybe you don't have as much snow, and we all get excited and think, yay, it's summer. And then guess what? It's not summer quite yet. Don't get your hopes up because we still have a month of March of snow, okay? Now, you can understand a bunch from this, okay? What month has the highest average snowfall? How much snow fell that month? Well, the highest point is found right here, okay? And what day is that, or what month? That's in December, which makes sense. And there was about 20 centimeters of snowfall, okay? What are the 3 months with no snowfall? Well, we just talked about it. It's June, July, and August, okay? So let's look at a few examples together. There's a written out example for you there, which you can look at. Let's do number 2 here. So use the graph provided to answer the following questions. Okay, so first off, always look at the title. Titles are really important and you always need to give a title. This is Katie's heart rate, okay? We can see that Katie's heart rate is the dependent variable. And of course, time is your independent. So if we look at Katie's heart rate, what's happening? Well, we can see that there's a big jump. So kind of note that there's a jump. I'm going to highlight that jump. That's the highest point. That's an important point, and that happened at 1 p.m. What happened at 1 p.m. to make Katie's heart rate jump so high? And then we kind of have here, which I would assume is her resting heart rate. Her resting heart rate, you can see, is falling kind of around 70 beats per minute. Okay, so let's look at this question first. So always analyze before you go to the questions. So what does the graph show? Well, our graph shows Katie's heartbeat. So Katie's heart rate over the span of a day. Okay, the times in specific are from 8 to 9 p.m. Okay, when was Katie's heart rate the lowest, and what was it? Well, the lowest heart rate, you can see, showed up 3 times. We had 68, 68, 68, 68. So these guys, she had 68 beats per minute, okay? And these were the lowest. When were they the lowest? Well, that one was at 8 a.m., 2 p.m., 5 p.m., 9 p.m. So 8 a.m., 2 p.m., 5 p.m., 9 p.m. And when was the heart rate the highest? Okay, and why might this have been? Well, we already kind of noticed that. It was 120 beats per minute, which is quite a bit. Beats per minute. And what time was that at? Well, if we look here, that was at 1 p.m. Okay, so if that's at 1 p.m., what was she doing at 1 p.m.? Maybe she went for a run. Okay, I'm going to say she went for an afternoon jog. So she went for an afternoon jog there. Because we can see that her heart rate over the span of about 2 hours was generally increasing and then generally going down. Okay, so from 12 p.m. to 2 p.m. we saw it go way up and then slowly go down. So I'm going to assume that she went on a kind of worked out. So maybe she did an afternoon jog, maybe she lifted weights, anything to get that heart rate up. Okay, as long as your answer makes sense, there's really no wrong answer, unless you tell me she was falling asleep there. She definitely wasn't falling asleep here. You could argue maybe she was asleep during this time, okay, because she was at her resting heart rate for an extended period of time from 2 to 6. So maybe she had about a 4-hour nap. Okay, so if any of that was confusing, please pause the video, rewatch it, and then come ask questions. Let's look at number 4 here. The graph below shows the values of particular stock that Vince bought over a 10-week period. If week 1 is when Vince bought the stock, use the graph to answer the following questions. Okay, so always analyze what the question is asking you and then analyze what this graph is. So first off, the graph below shows the value of a particular stock that Vince bought over a 10-week period. So let's make sure that's true. As you can see on the bottom here, this is in fact a 10-week period, okay? Then the value of that stock is on the left-hand side here, okay? So let's talk about that. He obviously started off week 1 at the lowest amount. That's what you hope when you buy a stock, okay? And then he had a really good few weeks. The price increased to $12. And then there was a dip, okay? There was a few dips, a rise, another dip, and then it kind of gradually stayed at the same. So what price did Vince buy the stock? Well, Vince bought the stock week 1. So this is $1. If we look, let's kind of zoom in here. I'm going to erase this actually. You need to know how much these are going up by. So if this is $3, okay, right in the middle of it, 1, 2, 3, 4, 5. right in the middle would be $1.50. Okay, so that would be roughly right here. So here's $1.50. Okay, if you want to figure out what each line is here, okay, what is each line? How can I figure that out? You can figure that out by saying, okay, well, actually I'm going to erase this again. Sorry about that. I'm going to make this a little skinnier. Okay. How many lines are there from 0 to 3? Well, there's 1, 2, 3, 4, 5. So to figure out what each line is going up by, you're going to do 3 divided by 5. Okay, and 3 over 5 gives me, and let's see if our cool little calculator works here. Right on, so 3 divided by 5. And I don't want it in that. I would like it in a decimal. So that gives me 0.6, okay? Now, that means each little unit's 0.6. So this is 60 cents. This would be $1.20. This would be $1.80. This would be 80 plus 60 gives me 240. And this dot here is what he bought the price at. And that is lining up with $1.80. Okay, so he bought it at $1.80. Okay, now since he bought it at $1.80, when was the stock worth the most? Okay, so the most is obviously the highest. Look for your highest value. It cost $12 on week 4. So $12, and I mean that's a little bit above 12, but honestly, if you put $12, I would totally mark it right. Okay, $12.15, whatever. It's $12. If it's that big of a difference, guys, you can barely tell, just round it to the nicest number, which is $12 in this case. Okay, and that's at week 4. Okay, so there's your question. So always analyze the question first, highlight what you need, okay, and then possibly start analyzing the graph before you even look at the questions. Understand the graph before you read the questions, okay? Now, we need to know how to make our own graphs, okay? So let's put a little notes over here, making your own graph. So when you make your own graph, it's really important to understand certain things. What you need is a title always, okay? You need a y and an x-axis, okay? You always need to state what this is, okay? You need to state what your x-axis is. So in this case, give it this a little title, and then also give the units. Same thing over here. What's your y-axis? And give the units. You need to make proper increments so they go up by the same amount on the x-axis and the y-axis. And that's pretty much it, okay? You always need your x to be the independent variable, and then your y to be your dependent. And remember, most of the time, you're dealing with time. So this is always going to be time if you have time in there. So let's look at number 5 and make that graph together. So Stephanie works in a pediatrician's office. One of her jobs is to track the growth rate of babies. So there is possibly a title, the growth rate of babies over time. The table below shows baby Jessica's weight for the first 12 weeks of her life. Draw a broken line graph of the data and discuss the trend. Okay, so we have to remember to discuss the trend. So again, what we're going to start with is and usually you want to use a ruler, okay? And what you're going to do, I wonder if I have a ruler here. No, I don't. That's okay. is you are going to set up your X and Y axis. And remember, if you're dealing with a time, it's always the X. Weeks is a measurement of time. So I'm going to put weeks here on the bottom. So that makes this the dependent variable. So I'm going to write my weight, and that's in kilograms. Okay, so now I have my two titles, but remember, I need a title for my entire graph. So what am I going to title this graph? Well, this graph is the, let's see here, baby Jessica's weight for 12 weeks of her life. So I'm going to write that. Jessica's weight over 12 weeks. Okay, now the last thing I want to do, remember, is put my increments of time. Remember, they have to go up by the same increments. So let's focus on our weeks first. Okay, if we focus on our weeks first, then we can focus on our age. So by focusing on our weeks, sorry, hopefully that'll go away. If we're focusing on our weeks, how many weeks are we dealing with? Well, we're dealing with 12, okay? Since we're dealing with 12 weeks, we need 12 increments here. So I'm just gonna go up by ones. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And recognize they're as even as spaced as I could make them. Okay, now let's focus on our weight. So for our weight, what's the smallest number? We're dealing with 2.4, and our largest number we're dealing with 5.1. And recognize how small some of these jumps are. Like this is 2.4 to 2.2, 2.2 to 2.6. So I'm gonna go up by, I need to be at least going up to 5.5. So I'm gonna go up by 0.5s. So this is gonna be 0.5, 1.0, 1.5, 2.0, 2.5, 3.0, 3.5, oh, I'm gonna run out of room, 4.0, 4.5, 5.0, 5.5. And sometimes this happens, okay? So how am I gonna deal with this? I don't know. Hopefully, I don't know if I can, I think that's gonna cut. Ooh, look at that, I can move. So you guys might not be so lucky in the fact you can just simply move something this easily. But I'm gonna move, actually I'm gonna keep this there, but I'm going to move all of this down. The benefits of having an iPad, hey? Look at that. Okay. So you might have to do a bit of erasing, pause the video, and fix your graph a little bit. Now let's plot these points. So we're gonna focus on this one first. So when she was 0 weeks old, she was 2.4. So as soon as she was born, she was 2.4 kilograms. So 2.4 kilograms, I'm gonna note that at here. 2.4 kilograms. So hopefully you can see that blue dot popping up right there, okay? Then we are on to, at the first week, she's 2.2. So find our first week, and it's roughly 2.2, so it's a little bit lower. Okay, second week's 2.6, so it's a little bit higher. Try and line it up as best you can with your 2, your second week. I'm gonna erase that. Your third week, you're at 2.9, so that's roughly right here. Okay, and you're gonna keep doing this all the way. So the fourth week, 2.9, same thing. Fifth week, she's at 3.1, so she gained a little bit of weight there, which is good. You want babies to gain weight. Sixth week, she's at 3.5. A healthy baby is a growing baby. Seventh week is 3.6, so a little bit lower. Eighth week is 4.0. So usually you'd use a ruler to determine if you're being really accurate. So 9, we're gonna go up to 4.0. So that's roughly here, okay? I'm gonna erase that actually. So what was 8? 8 was 4.0. Okay, 9, a little bit higher. 10 is 4.2. And then 11, and then 5.1. So there's your graph, and we can connect these points. Remember, a broken line graph, you're going to connect them the way it shows. Okay, so I'm going to connect all of these, kind of like this. So we can see at the start, she fluctuated a little bit. Okay, so she was fluctuating a little bit of weight. But if we talk about discuss the trend here is she's gaining weight, which is a really good thing for a baby. Okay, so there's your trend. She gained weight, and you can see that because it's increasing as the weeks go on. Okay, there's your general trend. So remember, we wrote a title, we wrote what each X and Y axis is, the units, and then discuss the trend. Awesome. So let's discuss a few more things here and then go on. So you should technically be able to do most of these questions at this point, okay? They're all very, very similar, so I'm not going to go through every single question with you, but we are going to talk about a few more. So here, a broken line graph may help you discover a regular pattern in the data. It may show a general increasing or decreasing trend, which can allow you to interpolate or extrapolate a value. So what does that mean? Interpolate is to estimate the value between two known values. Extrapolate to estimate a value beyond a known range. Okay, so I'm going to put that in more easier terms. Interpolate. What does interpolate mean? Interpolate means, like, as you can see here, we didn't take data points for every single week, okay? Here on week 4, we took no data point, but we can estimate, aka we can interpolate what that data point would have been. Okay, so this is an interpolated data point. Interpolated data point. Okay, because we can guess where that data point will be. Extrapolate is to estimate a value beyond the known value range. So we can tell we only went up to here, okay? But we could probably guess that the next value or data point would maybe be, maybe I'll do it in a different shade, would be this blue dot, okay? This was an extrapolated data value. Okay, because it's beyond. So interpolated, you can think of in as in the graph. We can guess where a point is in the graph. Extrapolated means it's exited the graph. So we can estimate where it is beyond the graph. Okay. So let's see here. Lumber is often priced in board feet. A board foot is a piece of lumber 1 foot long by 1 foot wide by 1 inch thick. The graph below represents the cost per board foot of kiln dried spruce over a period of 1 year. Okay, so we can see we have the cost of a board per month, and obviously it increases and decreases as we go. So what is the general trend in the cost? Well, we can see the general trend is that it's more expensive during the summer months than the winter months. Okay, so it's declining, which is an easy way to say it. Or if you want to be more kind of analytical, you could say summer months more expensive. And why would that be? Well, that's because people are probably buying this wood to build their docks and their decks and their outside things, where during the winter, it's not going to be as expensive because people don't want it as much, okay? The graph does not show the cost in August. Use the graph to interpolate, so guess where it'll be during the month of August. So the month of August, if we look here, is found right here. And if we follow this line up, our point would be roughly here. So that point roughly lines up with, I would say, around $325. So there's your $325. So we were able to interpolate, guess what that was inside. Based on the general trend in the data, how would you estimate the costs of the spruce to be followed in the next month of March? Well, since we're somewhat increasing here, I would assume that the month of March would maybe be a little higher. Okay, so I would say it's going to be around 325 as well. So between 300 and 325. And again, why do I know that? Because those last few months there are increasing. So I'm going to extrapolate and guess that the next data value is going to be a little bit higher than the original point beyond. Okay, so there is interpolating and extrapolating. And again, if you are confused or you write down these notes and it still just doesn't make sense, please come see me. So you should be able to do number 10 now. Give this one a shot and go from there. Remember a double broken line, okay? So a double broken line, you're gonna still do the same thing, except you need to give a legend. So actually, maybe I should do this one with you. Okay, so you have two things going on here. You have two sets of data, okay? And you can extrapolate. Now, anytime you have two sets of data, you need to include a legend. A legend tells you what is going on in the graph. So I'm gonna say that my purple line is my stock A, and my blue line, or let's make it red line, is stock B. Okay, and then again, I can draw my graph. This is June, July, August, so on and so forth. So June, I shouldn't have made that so big, yikes. Let's just say G-U-N, J-U-N, J-U-L, Aug, September, October, November, December, January, February, March, April, May. So I'm not going to do all the data points just for the sake of time, but I'm going to do the first few for sure. Okay, now if we look here, what's the biggest value I see? The biggest value I see is we get almost up to $3. So I got to make sure that I go up to $3 on my graph. So I'm going to write $3 right here at the very top. Okay, and then the lowest is pretty low. So I'm going to go up by 0.5. So this is 0.5, 1, 1.5, 2, 2.53. Now remember, we have two different data sets. I'm going to focus on stock A using my purple line. Okay, so stock A, we see here is $2.75 in June. Okay, so $2.75 in June. So that's going to be right here. $2.95 in July. August, $1.43. So that jumped down a lot of money there. So $1.43 in August. September, 0.81. So on and so forth. So you would be doing this, and then we would be connecting these points using a broken line graph. Okay. Now for stock B, it's going to be in red. Okay, stock B, June, it's $1.25. So that will be right here. July is $1.11. August is $1.32. September is $1.45. Okay, so, and now you would be able to analyze both of these different graphs using these lines, okay? What happens if you had the same colored pen? If I had the same color pen, I would have done this. I'm gonna make a solid line for stock A, and then a slashed line for stock B. So if you have the same colored pen, that's what you would do. Okay, and then you can compare these two prices, so on and so forth. So that's something you should be able to do. You're gonna do B and C, and I want you to finish this graph off your own, okay? Let's see what else we gotta learn here. Okay, let's do number 12 together, and then I think that'll be it for 2.1. So consider the two graphs below that show the percentage of the population of Alberta living in rural areas. So you have two different things. Recognize it's showing the exact same data. Okay, if you read these are showing the same things, but why do they look different? That's because they're using different scales. Okay, if we note, look here. This guy here, this right graph is showing more data. Okay, it has more data points. It's stretched out, so it helps us visualize what's going on. So sometimes that's how sneaky kind of maybe on the news, if they want to try and show you something and skew what you understand, they might mess with how these things are scaled. Okay, so which graph, let's look at A, which graph makes it appear that the decrease in rural areas was more rapid? Okay, well, the more rapid would be the left one. And why do they do that? Because if you look, they don't give as many data points, okay? Or instance, they have a bigger scale. They go up by more years. So they have a bigger scale. You might say, well, this one's physically bigger, but if you see, this one's going up by less amount of years. Which graph do you think better represents? So we're now on here. Which graph do you think is a better representation of the actual change in rural population? Well, it would definitely be the right, because it shows a more truthful graph. I mean, this is over a span of 100 years, okay? You should show a lot of data points for 100 years. Shows more data. Okay, use the graphs to interpolate what percentage of the population was rural in 1916. So let's use the left and the right and see if we get different answers. So let's focus on the left. Remember, interpolate, we're trying to figure out what it would be in 1916. So let's focus on the left graph, okay? And where would 1916 be? 1960 would be about here, and that will be roughly here, okay? And I'm gonna say that's around 65, okay? 65%. On the right, where's 1916? Well, it's a lot easier to tell. On the right, it would be roughly here, okay? And I would say that's more about 61, 62. Okay. You can tell that we got different answers because of their scaling differences. In what year was the population half rural and half urban? Okay, well, half is 50%. Let's focus on the left first. So let's find 50%. And that falls, ooh, that was a kind of a angled line there. That falls right between 1941 and 1961, so that's around 1951. Let's focus on the right now. So on the right at 50%, that's around pretty much 1951 on the dot. So we're doing pretty good on our guesses here. Use the graph to extrapolate what percent of the population will be rural in 2011. So remember, extrapolate means after. So 2011, I would say it's still a downward trend. Okay, but this one looks like it's going more to the right. This one looks like it's still going down. So I would say it's going to be roughly here, and that is about 17%. So that is how you extrapolate and interpolate data. And remember, scaling is very important because it can change how you interpret a graph. Okay, so I want you guys to try number one. You should be able to do this one now. It's remember, always look at your graph first and then answer. Okay, and then I want you to try 2 and 3 on your own as well. So these guys you should be able to do. And lastly, number 4. So there's a few questions to try out on your own, about 4 of them. And at this point, if something's really confusing you, you got to come in and ask questions.